Have a great day, students. Today we are going to see about the expression of electric field vector due to an electric dipole for a point which is too far away from the dipole. So here we can see the dipole which is made up of a positive and negative charge which is separated by a very small distance that is called as d. So you can see that clearly here. Now the dipole is mentioned as AB, where the positive charge is situated at A and negative charge is situated as B. Okay, so this is B and this is A. And from A to P, you draw a line. There is a distance from A to P. So since it is too far away, so that distance is mentioned as R1. And here from B to P, it is mentioned as R2, and this is R1. At the center, you have origin where the x, y, and z axis meet at this point, and from the origin to the point P, that is mentioned as R. Okay, now we are drawing a perpendicular from A to R2, from A to R2. So it meets at a point M, and it forms a right angle triangle with respect to this M. Okay, so AMB, it's a right angle triangle. Now here, let us derive this. So this triangle is taken here. Okay, so this is the triangle AMB, and the theta is mentioned at the point B. Here this is 90 degree. Now if you find cos theta value here, cos theta, so cos theta is equal to adjacent side by hypotenuse, so BM divided by AB, so BM is equal to AB cos theta. So AB is here, and AB is nothing but the value D, that is the distance between the two charges, so value D. So that is here D. So D cos theta. So BM is equal to D cos theta. So that is mentioned in equation number 2. And here you see PB, that is the distance from B to P, that is the point P. So PB, which is the sum of BM and PM. BM and PM. So this is already a perpendicular drawn here. So after this perpendicular value, perpendicular line, these line R2 and R1 are equal. So since they are parallel, they are equal. So R1 is equal to R2 in that case. So PA is equal to PM is equal to R1. So here you can see PB is equal to, the whole distance is equal to PM plus BM. Okay, so PM plus this value, PM plus BM. So that is mentioned here. Then BM is equal to, just if you want to find BM, PB, the total distance, minus PM. Okay, so PM. So that is equation number 3. And PA is equal to PM is equal to R1, as I mentioned earlier. So PA is equal to PM is equal to R1. So this is equation number 4. So PA is equal to R1 and PB is equal to R2. Now equation 3 becomes BM is equal to, since this PB is R2, R2 minus PM, and here this PM is that is equal to Pm is equal to AP, or it is equal to R1. So you can write it as R1. So Bm is equal to R2 minus R1. So here we come up with the equation number 7. Okay, fine. So now let us move on to the next equation. So here you can see, so Bm is equal to R2 minus R1. So already we know that Bm is equal to d cos theta. So from the right angle triangle we found that Bm is equal to d cos theta, and also we found Bm is equal to R2 minus R1. So d cos theta is equal to R2 minus R1. And we know that the potential is given by potential at a point is given by B is equal to Q by 4 pi epsilon naught into R2 minus R1 divided by R2 R1 into U. So here this d value, if the d value is very small, that is the distance between plus Q and minus Q, if it is very small, then you can write R1 is approximately equal to R2, which is again equal to R. Okay, that three distance from A to P, then B to P, and also from origin to P, these three are equal. Okay, so that is becomes R. So R, this is equal to R. Now this value becomes R2 minus R1 is equal to d cos theta, so that is substituted here, and R2 into R1 is equal to R square, so that is mentioned here. Okay, so this equation 9 becomes V is equal to Q by 4 pi epsilon naught d cos theta divided by R square into V. Okay, so here I can further do the further so here. Okay, so E is equal to minus delta V del V. So you know the value for del, that is dou by dou x, dou by dou y, dou by dou z. So that is sorry. So since it is v, dou v by dou x, like that. So here it is taken in the form of spherical coordinates. So r theta phi. So the value is like this. So minus del v. So minus dou v by dou r, and into a r vector plus 1 by r into dou v by dou theta into a theta, and 1 by r sin theta dou v by dou phi into a phi. So this is the general form. So okay, so generally it is mentioned like this, dou by dou r. So since it is v, so we have to use this v here. Now we have to find dou v by dou r and dou v by dou t, dou theta, and dou v by dou phi. Let us see how to find that. So here dou v by dou r is equal to dou by dou r of v. So that is v value already we found here. So the same value you can find, you can put it here. Q by 4 by epsilon naught d cos theta by r square. Okay, so that is equal to Q d cos theta. So dou by dou r. So what is the r term here? So this is 1 by r square is the only term. So other time you can take it as outside. So Q d cos theta 4 pi epsilon naught dou by dou r into 1 by dou by dou r of 1 by r square. 1 by r square. So here Q d cos theta by 4 pi epsilon naught into dou by dou r. So this 1 by r square can be written as r power minus 2. Okay, so if 1 by r means r inverse like this, so 1 by r square means r power minus 2. Now dou by dou r of r power minus 2, so you know that differentiation, it becomes minus 2 r power minus 3. Minus 2 into r power minus 3. So for the differentiation value you got this. So minus, you have to take here minus qd cos theta 4 pi epsilon naught. This r power minus 3, so you can write it in the denominator, so r cube. And here you can write the next slide. Let us see the next slide. Okay, so here you can see dou v by dou theta. Oh, sorry. Okay, so finally the dou v by dou r can be written as minus 2. This is the final value. This value is the final value for dou v by dou r. Now let us see dou v by dou theta. Dou v by dou theta, this value. Dou v by dou theta. Okay. Dou v by dou theta. Let us see that here. So dou v by dou theta is equal to dou by dou theta of qd cos theta by 4 pi epsilon naught r square. So here with respect to theta, so we can take the remaining terms outside. So dou by dou theta of cos theta. Okay. So cos theta, you know, minus sin theta. So minus qd sin theta by 4 pi epsilon naught r square. Now dou v by dou phi, there is no phi term, so that becomes 0. Now this E vector is equal to, if you apply that in that formula, so you will get this value minus 2 kd cos theta by 4 pi epsilon naught r cube into A r vector minus qd sin theta by 4 pi epsilon naught r square 1 by r into A theta vector. And so this here a minus value is there. So if you see the previous one, okay, minus del v. So here it is AR 1 by r into A theta. So minus is here already. So you can minus of minus, so it becomes plus. So here also a minus, here also a minus, so it becomes plus. So qd cos theta, this value is plus this value. Okay. So here r square is there, and we have 1 by r, so it becomes r cube. And the common terms are taken outside, qd by 4 pi epsilon naught r cube. So here also qd by 4 pi epsilon naught r cube, and it can be written as 2 cos theta into ar vector sin theta into a theta. So this is the value for electric field. Okay, electric field due to the dipole when a point P is situated far away from that dipole. Okay, and a few more things are there. That is dipole moment. So we can take the vector that is directed, vector length that is directed along minus q2 plus q, that can be written as d vector is equal to d into a z vector. Since it is taken along the z axis, so you can take it as d vector is equal to d a z vector. So its component along ar direction is given by dr vector is equal to dr vector into ar vector. So which is again equal to dA z vector into AR vector, which is equal to d cos theta. D cos theta. dr vector is equal to ds in dr into AR vector, dA z into AR vector, which is again equal to d cos theta. So d is equal to d vector is equal to d cos theta into AR vector, d cos theta into AR vector. So here also you have to put AR vector. So then the product Q into D. Okay, so you know that the dipole moment is given by the product of magnitude of a charge and the distance between them. So here this is Q into D. So we have D here, so Q into D, P vector, this is the dipole moment, P vector is equal to Q into D, so P into AR vector is equal to QD into AR vector, which is equal to QD cos theta, Q into D cos theta. So D vector is equal to, okay. And finally, potential due to this dipole is given by QD cos theta divided by 4 pi epsilon naught r square, and so this QD can be written, QD cos theta can be written like this, P into AR vector, so P into AR vector divided by, we can write in both forms, and E vector is equal to P by 4 pi epsilon naught r cube, since this P is equal to Q into D, so you can write as P divided by this value, and you can write the same value as it is. So this is in terms of dipole moment, we are writing this E as well as the potential, electric field as well as potential. Okay, right. Now let us see a problem regarding this. Let us see one problem. So let us see the problem first. What are the things asked? A dipole having a moment P vector is equal to, so the dipole moment value is given, P vector 3ax vector minus 5ay vector plus 10az vector. Now okay, so that is charge into distance, yes. So nanocoulomb meter is located at Q in free space. So the coordinates is given as 1, 2, minus 4, and find V, that is potential at P, at the point P with coordinates 2, 3, and 4. So the given values are P vector moment is dipole moment is given. We have to find V at the point P of 2, 3, 4 at the points. So the formula is V is equal to P into AR vector divided by 4 pi epsilon naught r square. So first, the located point is Q, and we want to find P. So RQP, that is the position vector, RQP. So it is given by RP vector minus RQ vector. So we know the values of P as well as Q. So 2 minus 1 into AX vector, 2 minus 1 into AX vector, 3 minus 2 into AY vector, and 4 minus 4, so that is 4 plus 4, and finally we will get AX vector plus AY vector plus 8 AZ vector, and we found we have to find R, modulus of R also. So to find this AR vector, you know that to find the unit vector AR vector, so you have R vector divided by modulus of R vector. So that is found using these formulas. So RQP vector, so this is determined, and modulus of R vector, it is given by here it is 1, here also 1, and here it is 8. So square root of 8 square plus 1 square plus, so 64, 66, so 8.12, and you can write AR vector, so that is, as I said, R vector divided by modulus of R vector. So by dividing 1 by 8.112, so here also 1 by 8.12, so 8 by 8.12. So you will get AR vector is equal to this value. This is the value AR vector. Now what do you found? What do you want to find? That is P dot AR. P dot AR. So in that formula we have that you can see this formula P dot AR divided by 4 pi epsilon naught R square. So first we found, let us find this value P dot AR. So we take the dot product of that. By taking the dot product, this AX that becomes 1. So 3 into 0.123 plus minus 5 into 0.123 plus 10 into 0.985. So from this you will get the value for P dot AR. So after taking all these values you will get 9.604 into 604. So it is mentioned as nanocoulomb, so into 10 power minus 9. Okay, into 10 power minus 9. That is because it is mentioned as nanocoulomb. So 9.6404 into 10 power minus 9 divided by 4 pi epsilon naught r square. So since we know the value for r, you can mention that also here, 8.12 the whole square. Here for epsilon naught it is already known constant value 8.854 into 8.854 into 10 power minus 12. So this is r square. So finally after substituting everything you will get 1.30915 volt. Okay. So in the previous formulas it is mentioned in terms of volt. That is what the value V is there. Okay, so that's about. So you just go through this problem and find the voltage here due to the dipole. A similar kind of so here they asked to find the angle also, theta and phi, so that you can find. So do it as assignment. Okay students, one more thing. So already we have seen some properties of dielectric, how the polarization takes place in the dielectric. Then what is non-polar dielectric, then polar dielectric. This is the properties, and what is dielectric strength. So this thing you should know. What is dielectric strength? So you know that all the dielectric material which is used in the capacitor, so they are of insulators. They are made up of insulators. All the dielectric materials are insulators, but all the insulators are not dielectric materials. So keep in mind. Okay. Even in interview also they will ask these kind of questions. So you know. So why they are not? All the insulators are not act as dielectric materials. So that is because in all dielectric materials there is not, they don't have the property of forming the dipoles. So when there is dipole formation, polarization takes place. So when there is polarization, we can say it as dielectric materials. Otherwise, you can't say that. So what is dielectric strength? So let us see that. So the definition is mentioned here. The dielectric strength is the maximum electric field the dielectric material can withstand. Okay. So before an electric breakdown. So if there is a breakdown occurs, then the conduction will take place. Okay, between the two plates. So if you have two parallel plate, so your capacitor is there. If you give more amount of field, it can withstand for a particular period of time. If you give more voltage, then it will break down. Okay, so that is the electric breakdown takes place. So the for the different dielectric material that will change. So that is the dielectric strength of that particular material. So ideal dielectric, theoretically, an dielectric material is a non-conducting material, but practically no dielectric is can be ideal because there is small amount of conduction may be there will be possibility of small conduction be there. That is because of the impurities present, then the cracks present, and due to the molecular misalignments inside, plenty of factors are there. Okay, so when there is electric field is sufficiently large, as I said here, when it is small, so it begins to pull the electrons completely out of the molecules, even if it is an insulating material. Okay, so when it is maximum, there will be a breakdown occurs, and that is called as dielectric breakdown. Okay, so that we can discuss in another one class. Okay, students, hope you have understood today's lecture. Meet you in another one video. Thank you.